Alright guys, this will hopefully be the last review we do on transport before we get to our end of year test. There is another video available on the YouTube and I will link that, but here is a 5-minute or less review of transport. Rather than a flowchart like you see here, I've decided that maybe a T-chart or graphic organizer might be a bit better. So we're basically going to go through the different characteristics we know about the different types of transport and identify which one is which. So the very first thing we know is that transport is moving stuff across the cell membrane. We know that we describe cell membrane as selectively permeable because selective means to choose. Permeable means to go through. So the membrane chooses what goes through. The biggest vocab word I think that we're struggling with is concentration gradient. Now, a concentration gradient, concentration means the amount of stuff, gradient means the difference. So a concentration gradient is the difference between the amount of stuff outside versus inside. So if I have 200 kids in the hall and 10 kids in my classroom, that is the concentration gradient. There's a difference between those two things. Now, which way do we move, with or against the concentration gradient, is our outline today. So the very first thing we know, there are two types, passive and active. So the two types of transport I have are passive and active. Now, each of these have different characteristics. The biggest difference between passive and active, we know from class, is that passive does not require energy and active does. So we're going to put here energy use, uses energy. Passive is yes. Oh, active is yes. Passive is no. So when using energy, think about active. It takes energy to be active. A passive person is someone who's kind of like, bleh, whatever, doesn't really matter. That's not a very energetic person. I don't think anybody's ever described Miss Humphreys as passive. I'm very active, so I have a lot of energy. The next thing we want to know is that concentration gradient. Concentration, or let's call it the flow here first. The flow here first. So we know that passive goes from high to low. We know that passive transport is the movement of any molecule from high to low, and it takes energy to go the opposite. Think about you're sitting in a lazy river. All you're doing is going from the area where there's a lot of people to where there's no people. You're floating through. It's carrying you. You've got a nice cold Dippin' Dots. You're chilling. You don't have to do anything. The active is going to go low to high. Now, if you think about a point on a mountain, if you're at the lowest point of the mountain, it's going to take a lot of energy to get to the highest point on the mountain. So active goes from the low point to the high point, and passive goes from the highest point to where there's less stuff. Okay, so that's the flow. Now, I want to make a note down here so that in order to move anything, you need either the concentration gradient or energy. I'm using one of those two things, either the concentration gradient or energy. So right here where passive, it says it does not use energy, it has to use the concentration gradient. It has to use it, so it's going to go with the concentration gradient. Concentration gradient. And again, don't judge Miss Humphreys, she can't spell. Concentration gradient, because it does not have energy, it has to have the concentration gradient. Well, active has energy, so it does not need the concentration gradient. So it's going to go against. It's going to go against. If I have energy, I'm against. If I don't, I am with. Think all your A's go together. Active, energy, against. And yes, energy starts with an E. But what is energy called in science? ATP. I'm actually going to put that over here. ATP. So, active, ATP, against. Passive, no energy, with, because you either are using the concentration gradient or energy. Something has to be moving you, okay? So we know passive does not require energy and goes from high to low and goes with the concentration gradient. We know that active does require energy, goes from low to high, and it goes against the concentration gradient. So now the only two things we have left is the subsections or types. So we're going to go types. Now, the biggest type of passive transport is diffusion. And diffusion is the movement is the movement of any molecule from high to low. So oxygen, carbon, water, whatever, blah, 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 all of it is moving anything from high to low. Well, if I'm moving water, if I'm moving specifically water, it's called osmosis. Osmosis. If I'm moving only water, diffusion is any molecule from high to low. Water, or osmosis, is specifically the movement of water from high to low. So we know that the relationship between these two is that osmosis is a type of diffusion. Osmosis is a type of diffusion. So we have diffusion, which is moving molecules from high to low, and we have osmosis, is the diffusion of water. The last thing we have are our types of active. Well, I'm moving something from low to high. I'm taking something where there's not a lot of it, and I'm shoving it into a cell that already has a lot of it. So taking things inside and outside of the cell requires energy. Mr. J had a great example of opening and closing a door. You have to move the door. That takes energy. So opening and closing the door takes energy. So these are types of active. We have exo, and I'm honestly fine if you call it exo and endo. The next word is cytosis, which means to enfold, but exocytosis is a very difficult word to say. Endocytosis is not fun. So I'm good if you call it exo and endo. Fix my spelling. Exo and endo. And exo meaning outside. Exit means take outside the cell. And exo sounds like exit, so endo sounds like into. So inside, takes stuff inside. And that, ladies and gentlemen, is transport in 7 minutes or less.